All right, we are back in the interlude with is it the Arizona meetup? What is this? It's called the Scott Guthrie event. Tell me.
Arizona Scott Guthrie event, AZGroups.
Arizona Scott Guthrie event, AZGroups.
AZGroups is the user group.
AZGroups is the user group is what they're telling me. So this is Scott Cade who runs this fine shindig. He let me come backstage, in between to talk to some interesting people about some interesting things. I will try to be interesting, but I know for sure you will be. Tell us who you are.
I hope so. Yeah, I'm Rob Bagby. I work in TED at Microsoft, and I basically work in the container space.
Awesome. So I could take that one of two ways. It could be like you work in a container space, or you work in containers.
My office is just tiny.
It's just a tiny container.
Cube-like.
So for those of us that are old and stodgy, like me, programmer-wise, how do I even start to even with a container? I want to understand what a container is. How would you go about explaining that?
Yeah, it's amazing because right now containers are at the very top of the Gartner hype curve. It is if you can tell when it's that hypey when senior management starts talking about it, in odd moments. So to me, I think about containers this way. It is a structure that allows you to basically encapsulate all of the dependencies along with your application. Okay. The complete file system, all the dependencies, and your application. When you were talking with Jerry earlier, you guys were talking about some common problems I hear all the time. Sure. I've got .NET Core 3.5 or 3.5.1 or whatever. I need to make sure this thing works. That's a common problem. It's the works on my machine scenario.
Sure.
But that works on my machine, that's kind of painful, personally, but as an organization, works on staging but doesn't work on production, even though those are the same environments, is very common. And that's the problem that container solves. The one thing somebody should understand about containers is it encapsulates dependencies, and that solves a bunch of problems. It solves that works on my machine. It solves that works on staging, not in production. It solves the problem of application density. Because how could I have two unlike units running on the same server? Well, I can if there's this container that's encapsulating the dependencies.
So let me see if I understand this right, because so I understand VM and I understand a framework.
Yep.
It feels like container is in between somehow. It's not a VM, it's not a framework?
It's a separate level of virtualization. So VMs virtualize hardware. VMs virtualize the operating system. And so if you want to have a VM, carries its own OS with it. And so it's fairly heavy. It solves problems, solves a lot of problems out there, but by its very nature, it's fairly heavyweight. So containers run across a shared kernel. And so they don't carry that same amount of weight. And so you can have more containers running on the same piece of hardware than you can necessarily VMs.
I see. So, okay, and here's my ignorance coming out, and so you're going to help me be less ignorant. Let's just say I have an application that's a Ruby application that I know works well on Linux, and then I have a .NET Core application that I know works well on Windows. Can those containers live in the same space? Because I'm trying to understand, is it virtualizing a specific OS or many OSs? Sort of help me with that.
Yeah, so you can't mix Windows and Linux on the same box unless you have a hypervisor sitting in the middle.
I see.
And so you could, theoretically have two VMs, one that's running basically a Linux host and another that's running Windows, and then you could have a multitude. But the difference is I could have, say, Debian and Ubuntu all running on the same Linux kernel. And if I had multiple flavors, which we don't right now, but as we start getting multiple flavors of Windows Server that support different that support Docker but different versions, those could all run on the same kernel.
I see. So then you effectively are creating a VM wherein the containers sort of live.
A lot of times, especially in the cloud, it is a VM. You could run them on the metal, though. I could have a server that's got Docker installed on the metal, and I've got a bunch of containers on that. Or you could have a VM running that's got a bunch of containers.
I see. So you're saying, like, I have a Windows machine, I install Docker. Effectively, what I'm creating when I'm doing containers are Windows containers that run foo and bar.
Right. You've got a Docker host, and then you've got containers up there that are doing what they do, and nobody else cares about it because they encapsulate everything.
So we started talking about containers, and then we started mentioning the term Docker. So why don't you sort of help people understand what those two have to do with each other?
Sure. Yeah. So containers have been around for a long time. There are a lot of basic technologies that have been built to enable that. Things like AZGroups and namespaces and a layered file system. And so you could do containers for, for ages. In fact, if you look at Mesosphere, they've been doing containers for a long time. However, Docker basically took all of those technologies and made it really easy. They basically gave you an environment that makes it easy to create containers. And so now there's a specification. And most folks tend to adhere to that specification. So Docker also has it's an overloaded term, which makes things kind of challenging.
This is why we talk to people that know stuff. Okay.
You've got Docker the company, you've got the specification, and then you've got things like Docker Trusted Registry, and you've got Docker Swarm. There's a ton of technologies out there, but really, when you think about most people tend to think of containers and Docker as the same thing, although that's not necessarily correct. In the mainstream, most people are supporting the Docker format, and so it's okay to think like that.
I see. So if I want to start using containers and I'm on Windows 10, right? What is it that I have to do? Do I have to install like a special VM? Is there? Because I remember early on I had to install some other thing that didn't work, and but I hear it's a lot better now. Why don't you tell us about the experience now?
That's exactly right. If you're on Windows 10, specifically the anniversary update, you can install Docker for Windows. And that's one of the Docker 4s. And Docker for Windows basically allows you to run both Linux containers as well as Windows Server containers on your machine.
At the same time?
Not at the same time.
Okay.
You basically can go into the toolbar and you choose switch to Linux or switch to Windows depending on where you are.
And it handles the virtualization.
It handles the virtual, and that's exactly what it is. You have to have Hyper-V enabled, and basically we have a VM that's very lightweight, that's optimized for running containers, that's running behind the scenes. And those containers, those Linux containers, are running as is. So it's interesting in that Windows, running on Windows, you have the most powerful development environment for Linux, because it's right now the only place you can do Linux and Windows Server containers.
That's quite impressive.
That is kind of cool.
Because the thing about it is, like, I'm like, hey, I built this .NET Core application, but I want to make sure it works on Linux because someone might want to host it. Maybe I'm selling the software. You can literally test it on your Windows machine into a Linux container.
And that's the goal. The goal is to be able to have developers working productively on whatever system they're working on, build out the proper image, deploy that image to wherever their registry is, be it Docker Hub or Docker Trusted Registry or our Azure registry, and then it will just run. So you can build it on your machine using really powerful tools now in Windows, and then you can deploy it out, and it runs exactly as it did on your machine.
So you mentioned something called a registry. Would you explain what that is and why I should know about that?
Yeah, if you think about the easiest way to think about it is if you think GitHub is to source code as Docker Hub is to images. It's a place where images are stored that you can then access them from other environments. And so GitHub is kind of the open to the world, and I'm going to put my code out there. Typically, most repositories are public.
Sure.
And in Docker Hub, you've got public images, but you might also want to have your own local repository. And so you can use Docker Trusted Registry for that. There are a ton of other registries out there, and we have one in Azure as well, so that if you wanted to have the registry running, say, inside of the same subscription as maybe you had a cluster running, you can do that.
So you mentioned the term image. Is that because I know it for containers, it's not necessarily the OS. What does the image represent? Like what's inside of an image for a container that you would sort of download?
Sure, you create, the first thing you do is you create basically it's a text file that follows a specification. And then when you call build, that actually builds an image. And it's a series of layers. And that's kind of the cool part about it, is because the tooling and the differing infrastructures can cache those layers.
Right.
So earlier Scott was talking about, hey, I've already built this thing once, so it's not up in the environment that I'm deploying to, so I don't have to deploy, say, 2 gig. My changes are sitting on the last layer, and they have to deploy that layer out there. And so an image is really a series of layers that define really the file system, your dependencies, as well as your application code.
And so now that we've sort of got a little bit of a better understanding of containers, now it feels like we need to up level, and we need to start talking about, well, like it feels like my application is going to have a bunch of containers sort of interacting with each other. how do I build that properly, number one, and number two, how do I know if it's healthy or not?
Yeah, so you basically, you split it exactly right into two separate questions. One is the architecture, and you talk about, there's a lot of buzz around microservices today.
So that's the term that people use when they're talking about containerization of applications.
I think it's what's most commonly used.
Okay.
The most typical path today is you don't have to break an application down in order to containerize it. You can containerize a monolith just as easily as you can containerize a microservices environment.
Sure.
So the typical path people follow is containerizing the application itself, and then where it makes sense, they break it down into services, or what's buzzed around now are microservices. And so there's a lot of really good text out there about building microservices. There's a great book by O'Reilly that's published out on O'Reilly that talks about microservices and its relationship with containers. That's quite helpful. Mm-hmm. The net is when you start to break an application up, you need to think about responsibilities. What are the proper responsibilities of each of these pieces of my application? And Jerry and I were having a conversation about this earlier, and he brought up the example of Jerry. What was the example we were talking about with microservices? You were talking about your web.
We were talking about figuring out taxes, figuring out shipping.
Oh yeah, in an e-commerce application.
Okay.
So in an e-commerce app, how would I start breaking that up? Well, think about search. So when you're going to store data for search and you want to have a viable search, what is the viable backend for that? It may be that like Lucene or Azure Search is a really good backend for that. But what about storing, say, my product information? That kind of seems like I might want to store that as JSON. So maybe I want to use something like a Mongo or a document DB. Right. And then if I need something that scales massively, maybe I want a document DB, or maybe I want something like Cassandra. Well, so you break your services down into these areas of responsibility that have this kind of clear bounded context. Sure. And then you get all these additional benefits of things like polyglot storage. So I can store in backends that are optimized for that services for its need. I tend to think superpowers. What superpowers do I need for that for that service?
And that's an interesting sort of way of thinking about it. However, the challenge I always have is I come from old school. There was one database.
Right.
That might not be the case with microservices.
No, in fact, it's generally not the case if you've done correctly. It's a challenge when talking with people that haven't done it, because they have to buy into eventual consistency first. In the old days, it was evil to have data stored in more than one place, the same data stored in two places. And today that's not the case. As long as you can guarantee that data is consistent in a time that's viable for whatever your business requirements are, then you can take that data and have it stored in multiple places that are optimized for whatever that need is. And that typically means that you've got to have some sort of guaranteed delivery of messages. And so service buses are typically sit in between data as it's being stored in multiple places.
And so you just sort of put something on the queue, and then everyone who subscribes to that is like, hey, I need to make an update to my
That's
stuff.
exactly right. And if you have message semantics in there, you can guarantee you're going to get retries with exponential backoffs. And if something fails, it's going to go into a queue where you know it failed, and you're going to be able to react to it.
So that leads us now to the health of these things.
Right.
Like, because I mean, when you have one microservice that's like the front end part of the web app, and all of a sudden it's starting to get a little clunky, how does it say help? I need help, right? How do you do that?
Yeah, so I think backing up, I really like how you put it. If you have one microservice or one container, it's really simple. Mm-hmm. But when I start having dozens of them and thousands of them,
I just try to make it easy for me to fit in my head.
It gets massively complex because I already kind of described what I believe the problem that container solves, and that's that dependency, carrying the dependencies with it. But if you start buying into containers and you start moving in there, you just brought up the fact that a whole new set of problems come about. How do these containers talk to each other? How do they know what else is available? What happens when one goes down? How do I make sure it gets brought back up? How do I scale them? How do I monitor them? All of these are additional concerns that now crop up, and that's the role of things called orchestrators.
I see.
So if you've heard of like Docker Swarm or DCOS, Mesos and Marathon or Mesos and Kronos or Kubernetes, that's the role of that layer to help you to orchestrate these different components or these different containers, make sure they stay up, make sure you can add metadata in telling them, oh, I need to have at least 3 of these services up. These are running in a private cluster, and I want them load balanced from this public cluster.
I see. So there is like these orchestration tools, excuse me, that will sit there and monitor the containers, or the containers talk back, or is there something I have to do to my code? I mean, I'm trying to understand, like once the load on a particular container reaches X, for example, how do I tell the orchestrator to spawn a new one?
So the orchestrators all differ in that respect, but essentially the container, they all have support, at least the 3 that I mentioned are probably the 3 most prevalent out in the world today, and they all have support for containers. Now, again, you're not going to be able to create something that does everything, and so most of the orchestrators have additional partners that work with them that plug into those environments. So a really good example is, in fact, now you're kind of getting into what my actual job is with Microsoft, is working with those partners and how they integrate with things like Azure Container Service, which we can get to in a second.
Absolutely.
So say you want to monitor your service. You can use App Insights, but maybe you're a sysdig shop. So how would I get sysdig to integrate into with my orchestrator that's managing all my containers, and how can I get a view into each of those specific containers so that I know when something goes wrong, what is it?
That's interesting, right? Because like distributed systems are hard. And effectively when you're containerizing, you're building a distributed system. And so these orchestration tools are meant to help you. Are they all super different? Are they all similar? Is there one that you would suggest that I should look at first if I'm going to do this? What do you suggest?
So they all have their own, their own kind of iterative strengths.
You love all your kids the same?
I love all my kids. They're all beautiful, and I work with. I've worked with all of them.
Okay.
And so I wouldn't tell you, use this one over this one. I would suggest. It's interesting when you look at the container world and where we are today. We're really at the forefront. This is the kind of the very beginning.
Right.
And so I have no idea what it's going to look like 5 years from now. So what we do, or our strategy at Microsoft, is let's give you choice. And so if we look at Azure Container Service allows you to basically deploy a cluster and you can choose which orchestrator you want. And recently we added Kubernetes, but now so now we have Swarm, Kubernetes, and DCOS. And so really you can choose whatever you want. You can try them out depending upon maybe what your staff strengths are. You can choose those. But
so Azure Container Service then is like, I have my containers, I've done all this stuff, I've chosen my orchestration tool. This is where you just sort of put them up to go live. Is that what container service is, or am I not understanding it right?
No, I think you're pretty close to hitting it on the head. If you think about what these orchestrators are, they're mainly based around open source technologies. So DCOS is Apache Mesos and Marathon, which are all open source. Kubernetes is completely open sourced. Docker Swarm is open sourced. So ACS, the way our ACS team runs it now anyways, is that in order to be an ACS, you have to be completely open source. And so if you were a company and your goal was you wanted to run an open source solution, an open source orchestrator, if you will, your best choice would be to use ACS because we will deploy it for you, as opposed to having to, imagine that you wanted to deploy out Mesos and Marathon all by yourself. The amount of effort that would be to basically build up the infrastructure properly, the load balancers, the scale sets, the IPs, and make sure it's locked down. And once you get that, if you're sure you've got that, now you've got to install the software.
And then you got to put the containers out there, and then you got to see if they're healthy. It feels like I would literally lose all my hair.
You kind of want to, and that's what happened when I
started. This is why I wasn't going there, but he did, okay?
So ACS allows you to deploy out the orchestrator properly. And it's a matter of just simple configuration, and we'll deploy out a proper cluster that has the appropriate, I've got a private cluster, I've got a public cluster that I can put my load balancers in, and we'll do everything kind of by the book for you. And that's the benefit of what you get with ACS. Now, some companies want to take a step further. They want to have some of the additional, I guess as they say in England, the additional bits and bobs out there that are added in by, say, Docker Data Center, or Mesosphere has an enterprise DCOS, and then you can get on OpenShift. They basically run Kubernetes behind the scenes, so you can utilize those solutions, and you get additional support from those companies.
I see.
But here's where the break is. Here's where the logical break is. If you wanted to run Jerry Nixon, ladies and gentlemen, Jerry Nixon.
He is not a crook.
I am not a crook. If your goal is to have the open source version, use ACS. If you wanted the additional things that are offered through either Docker Data Center or Enterprise DCOS, then you would go there.
I see.
That's where the break is, and I think that's where there's a lot of confusion.
So is there like an ACS like file new and then things happen?
It's ACS. Well, there's the universe in DCOS. Again, it depends upon which orchestrator you use. If you use DCOS, you can go into the universe and you can deploy a series of things that are in the universe.
Like when you say you just go to the universe and you make it happen, it sounds like I'm like a Marvel hero.
There's actually
it's like Super Seth is going to go into the universe and tell it what to do, and the universe will just happen.
You might feel like that when you click on the universe.
Is it called
tab.
the universe?
It's called the
tab?
universe. Yeah.
Okay.
So you click on the universe tab. In Swarm, you can go to Docker Hub and pull anything down. Kubernetes, you can pull out of Docker Hub as well. So ACS is all about deploying out a proper cluster for the orchestrator of choice, and then allowing you to. Now, there's going to be additional things that ACS will be going forward, but for now, it's deploying a cluster properly.
So let me ask my producer, how much time do we have, Golnaz? She's telling us. I have more questions, but I don't want to.
People are coming in, so I'd say 5 more minutes.
People are coming in and say 5 more minutes. To finish up then, because like we talked about containerization, it feels like there is an even smaller bit of things that you can do with Azure Functions, right? Because it feels like we have our VMs and then we have our containers, and then it feels like Azure Functions are like the, like the fast, awesome, like tell me about those and how they're similar to containers but also different.
Yeah, so I mean, functions could take advantage of containers. You could containerize functions. Now, I'm not an expert on how functions are organized right now. However, a function is, to me anyways, how you can very easily run a piece of code without having to host it in an environment. Containers are about how do you deploy it. So you could imagine that I deploy my function in a container, and then it runs when a trigger occurs.
Sure. So it feels like it's like a function. It's a single function. It feels like even a unit of sort of execution. Well, this has been super helpful. You're going to be coming up hopefully in a little bit.
I will.
You're going to be talking about, what are you going to be talking about?
I'm going to be talking about containers and the pretty much what we talked about today.
But with demos, right?
Yes,
are
demos.
You going to show ACS?
Yes, I am.
Oh, thank goodness, because I'm sitting here trying to imagine the
I'm going to show the universe.
The icon they picked for the universe button. If it's something boring, I'm going to be very upset. Thanks so much for spending some time with us, buddy.
It's my pleasure.
Thanks so much for watching. Again, we're here in Arizona for the Scott Guthrie event. Stay tuned for Jerry Nixon, and this good gentleman is also going to talk about containers. Thank you so much. And then Scott Guthrie has an Ask Me Anything AMA starting at 4 o'clock. So stay tuned for that. Thanks for watching, and we'll see you after the break. Take care.